6-4 says there's two types of moves that you could use in problem 6-3 to simplify expressions with algebra tiles. First, you could remove matching or balanced sets of tiles from both sides of the mat. Second, you could remove zeros. Both of the moves are shown in the figures below. Justify why each of these moves can be used to simplify expressions. So when they're talking about this, what they're saying is that we have to explain why these work. Why is it that we can remove balanced sets from each side and why we can remove zeros from one side? So on removing balanced sets, why does it work? Hopefully you're thinking that it's because we're removing the same quantity from both sides. And in doing that, it maintains the relationship still with mat A and with mat B. So with this one here, we can remove the same shape, balanced sets because we are removing the same quantity, same value from both sides. So it maintains the relationship between mat A and mat B. Because if we start to mess with the relationship between mat A and mat B, we're never really going to know which one is greater. So for the other one, it says our other legal move, you can remove zeros. So why is it that we can remove zeros right here? Why is that legal? We're removing a zero. It's not that a zero has no value. It's that it has a value of 0. And so it doesn't change anything. So if I'm looking at this picture right here, I see that I have 1, 2, 3, 4. Try not to move the whole thing. But 4 positives plus 2 negatives. 4 positives plus 2 negatives is 2 positives. So if I remove these 2 0 pairs, I'm still maintaining that 2 positive value. That's why it works. We can remove zeros because their value doesn't change the value of the mat. Which again, because it doesn't change that value of the mat, in that case a mat B, that relationship between mat A and B still stays the same. So their value, because their value is 0, it doesn't change it, just like we did with the integer tiles, where we were adding integer tiles. We were adding zeros to be able to have enough to take away. Same thing here, we're removing those 0 pairs. It doesn't change that value. So I want to make sure that we're good on this because it does become kind of confusing for kids sometimes. And we use this to be able to help us to simplify expressions and inequalities, and later we're solving equations with these. And so I want to make sure that we're good. So I set up a variety of tiles right here. So if I am removing a 0 pair, a 0 pair has to be on the same side. And the reason for that is that if I remove this -1 right here and this +1 like this, what happens is that I'm changing the value of both of them, but in the opposite direction. And so now suddenly it's going to be much, much different than what that relationship was between these two to begin with. The other thing is that I can remove the same shape, same shade, as long as they're on different sides. I can't start removing these two because again, that's really going to affect my value. If right now X is equal to 3, if I remove these two right now, I just dropped this mat by 6 units. That's a big difference if I'm not going to do anything with this. It's not even, it's not balanced. So instead, when we do these things, we want to make sure that our 0 pairs are on one side and removing our balanced sets are going to be on the same side or different sides. Good gravy. It's time for Mrs. Fox to go.